we have talked about data collection and the proper SI units, we're going to look at uncertainty of measurements. Uncertainty means how accurate or how close you are to the actual value. There is a variation in our numbers based on the equipment, and that gives us an uncertainty value. It's like you're not sure it really is, but then you think it is. And so we're going to look at measuring, again, we want to work on facts, that uncertainty in the numbers that we have taken. So we'll look at the two things that really affects us. One of them is the equipment itself. How good is our equipment? How accurate or how exact will it measure, in other words? And the other thing is the person using the equipment. Are you using it correctly? Do you know how to read the measurements on the scale on the piece of equipment that you're using? So we have these two variables to look at that affect our uncertainty principles. So valid data is based on accuracy. Accuracy is measuring as exact as possible, or should I? So accuracy is really looking at, did I really measure this correctly? And we want to be as correct as possible as we're doing our measurements of our base units. So it's how close is the measurement to the accepted or true value. Sometimes we will know what those true values are, and sometimes we have to, after many trials, come up with that true value in order for us to have a standard of what that value should be. And then we look at precision. Precision is looking at when you're measuring multiple times, as we do with data, how close are your measurements to each other? Are they all falling in the same range? In other words, within the same amount of values, or are they all over the place? And so this precision makes a big effect on our accuracy. We want to not only be precise, measuring similar values every time, but we also want them to be accurate. I can give it to you with the example of the old saying of practice makes perfect. Well, no, it doesn't, because I can practice incorrectly how to do something and I'll never get it perfect unless I practice perfect to begin with. Perfect practice makes perfect. So we look at accuracy and precision. Now, data, like I said, should be both accurate and precise. We want to be both, not just one. Really, we want to be accurate most of the time. But sometimes, because of our limitation with our equipment, we can only be precise. Now, how do we deal with that if we're limited to our equipment not being very good? Well, we look at a value that we call percent error. Now, our percent error is based on what numbers we actually calculated and the actual accepted value. So we can calculate accuracy by using this formula. It's percent error. We want to know how close we are. It's going to give you a grade if you want to look at it that way. And by taking your measured value, subtracting it from the accepted value, or what it really should be, dividing by that accepted value, multiplying at the end by 100. You need to make sure you do this first, subtract these two first before you divide and then multiply. So keep that in mind. Order of operations is something you really have to focus on. So the measured value, like I said, is based on the data collected. That's what you literally measured. And then the accepted value is what the true value should be.